The XML world uses, well, in HTML it was called a catalog, and in XML I think it's called a resolver. And when you call libxml, I know it through Python, but I'm sure it's the same in other platforms if you use the DirectC interface. When you call libxml, you supply a resolver. You have to supply a resolver to explain where the stuff is coming from. So you can't say input this file. In XML, you can't say input this file without, you can say input the resource that has this name. But when you run it, you have to specify what the resolver is. And that is, in the XML world, a mature technology. And it's actually not an operating system feature at all. The resolver is supplied. The operating system might supply a resolver, but the choice of the resolver is a choice made by the personal program that's calling the transformation. But that's looking ahead to 2050, you see, when maybe everything likes this brave new world. I'm just looking to 2022, 2023, where the style files are stored in Git packs, and if we store the files in Git packs and provide suitable means for unpacking them, nobody will know any different. But the nice thing about doing it is that you can store all the files for all the versions you're interested in without having to store multiple copies of the same file. And the other nice thing about it is that when you get the file, you effectively get a secure hash with it. A small change that would be useful is that when you run tech, you can use a command line option called recorder, and that creates a file called jobname.fls. And that gives the path to all the things that are input. If it also gave the key that was passed and the secure hash of the object that was returned, that would be extremely helpful in terms of reproducibility. So a sort of an enhanced recorder. So what I'm thinking as one of the things is to make it easier, much easier, to run tech and get not only a typeset output, but if you like, in mathematics, there's something called, there's some people, Doron Zielerberger is one of them, who has software that produces, that checks hypergeometric identities, which are traditionally laborious and ingenious. Hypergeometric functions were studied by Gauss. And this system, when it works properly, it either produces a counterexample or what's called a certificate. And a certificate is basically a proof. A certificate that a number is prime is a fairly complicated thing. A certificate that a number is composite is simply a factorization. So if we do a typesetting run, and from this we can produce a certificate that says, here's the typesetting run, here's the inputs, and here's the outputs, and here's the data about the engine that did it, that would take reproducibility a tremendous way forward. And it would be completely in line, for example, with what the LaTeX team are doing regarding accessibility, because their objective is to run existing documents through an enhanced version of LaTeX and get tagged PDF out as a result. Well, if I've written my thesis and in 5 years' time I want my thesis to be accessible, the first thing I want to do is reproduce the typesetting of that thesis as it was 5 years ago. and then I add the accessibility. So that's already a deliverable that happens to use Git pack files as a way of storing everything. Just that here's an efficient way of storing everything. And the great thing about somebody that sends you a Git pack file is because you've got secure hashes for everything, you can check what they've got in their tree with what you've got in your tree and see whether they're identical or not. And you can reproduce the calculation.